Hi class, this is our 7th online lesson and our 6th in the series of dynamics. In the previous video we learned about rough surface and the frictional force. Now we'll go into a relationship between the normal reaction force and the frictional force. What is the relation between them? So there's a maximum frictional force. The maximum frictional force is given by mu r. R is the normal reaction, F is the friction. Mu is the coefficient of friction. It depends on the surface and the object. Okay, so this is any constant. Now to understand F max, I want to give you an example. Let us say a small kid is pushing you. Now obviously you have a lot of power. Okay, let us say you have a lot of resistance force to push back the child, but you're playing with the child. If the child is, let us say, applying a force of only 1 Newton, although you have a capacity of much more, you only push back with 1 Newton force just to play with him, let us say. If he applies with 5 Newton, you push back with 5 Newton only, although you have a capacity of 50 Newton, but you're playing with the child, so you don't push with all your force. So there is a maximum capacity in you, but you're not using it because you don't need it. Newton's third law, if somebody's to give it equal and opposite reaction and you're playing with the child, and I'm giving you an example just to understand this concept. So if somebody is pushing you with 5 Newton, you're just pushing back with 5 Newton just to have fun. Now the same thing happens, and let us imagine now the opposite person is not a child. Now he's almost something similar to you or stronger to you. Now let us say you have a capacity to push back 50 Newton. Now if he pushes you with the 40 Newton force, you push back with 40 Newton. And then if he pushes with 50 Newton and that is your maximum capacity, you push back with 50 Newton. Now that is called limiting equilibrium. Now you reached something where the forces are balanced. That is called limiting equilibrium, about to move. And now if that person applies 60 Newton force and you can only bear 50 Newton, obviously you will start moving backwards. So now you are accelerating. Now the object is moving back with a resultant force of 10 Newton. Now this is what the maximum friction is all about. Now let us understand. That was just an example to give you the idea about what F max means. Now when a table, for example, if table is there on the floor, and let us say the capacity of the table because of the floor's friction and the metal or the wood, whatever particle the table is made of, can push back 5 Newton, for example. The capacity is 5 Newton. Now if you are pushing with 1 Newton, it will not push back with 5 Newton. Newton's third law, you're applying 1 Newton, the force in the opposite direction will only be 1 Newton. If you apply 5 Newton, then 5 Newton will balance, limiting equilibrium. But if you apply 6 Newton force, then you are actually pushing the table. The table will actually start moving. Now this is what it is all about. So that is that maximum friction, which is given by mu r. Let us take example to understand this now. Okay, in this question exercise 5c, each of the following diagram shows a body of mass 5 kg lying initially at rest on a rough horizontal ground. The coefficient of friction, that mu thing, the mu is 1 by 7. Okay, whatever, you can read it. In each case, find the magnitude of the force F, the friction. State whether the body will remain at rest or will accelerate. Okay, and when appropriate, find that acceleration. In the next slide, I'll take the same example. Okay, let's go to the next slide. Okay, the same example from the previous slide. Find the magnitude of the force now. See, let us do this question. Okay, if I resolving up as positive, because it's not in motion vertically, so this will balance this. So we know R is phi g. What we first do is, let us find the mu r factor. I call it, this is my way, let us call it the mu r factor. So mu into r, we know mu is 1 by 7. So 1 by 7 into 5 into 9.8 will give you 7 Newton. Now this is the same mu r, that formula F max equals to mu r. This is the maximum friction, the maximum capacity, you can say, or maximum friction. Now since only a 3 Newton force is applied, it will only reciprocate with 3 Newton force. So the friction will only be 3 Newton. Although the maximum it can go is still 7, but because only a 3 Newton force is applied, it will push back with 3 Newton. The friction will also be only 3 and the object will still remain at rest. Okay. In this case, question C and A, forces are, everything is same except this is 12. So you don't need to solve this again. Okay. Now F max we already did, it is 7 Newton. But this time, previously it was 3 Newton, now it is 12 Newton. So now, because the maximum friction can only be 7, if you apply a 12 Newton force, with the result in the net 12 minus 7, the net extra force of 5 Newton, the object will start moving or start accelerating. Okay, and now see, if you see this designer F, on purpose I made it like this so that you're not confused with the resultant force and the friction. By this F I mean the resultant force is mass into acceleration, the formula we have been using. So resultant force, if I take this as positive, it will be 12 minus 7, or we did from here 5 is mass into acceleration, and hence you can get acceleration is 1 meter per second square. Let's go ahead. Okay, I'm taking this example L here. Now this is the mixture of what we just studied F max and the previous video of resolving the component. So this, because this is neither horizontal nor vertical, we need to resolve the component. Okay, always go parallel to R, as I told you. If we go parallel to R, this becomes vertical, this becomes horizontal. Opposite, that's why it's sine, so 56, sine 45, adjacent, so cos. Okay, see, they gave you this as 45, but obviously this will also be 45, so I just took this as 45 instead of this. It doesn't matter. Okay, and now resolving again, up in this vertically it is not in motion, so upward force will balance the downward force. So upward force, there is only R is the only force which is upward. These two are downwards, Fg sine 45 and phi g. Okay, you know R, again find that mu R factor like we did before. The mu R factor, mu is 1 by 7 times this will give you 12.675 Newton. This is your max frequency. Now force applied. Now what are the forces applied? One is this 56 cos 45. There is only one force, which is 39.6 Newton. Now obviously 39.6 is greater than 12, so object will definitely accelerate. Clear? Let's see more about this here. So again, because the job is to find acceleration, this designer F is resultant force is mass into acceleration. If I resolve right as positive, this 56 cos 45 will be positive, F will be negative, and you simple mathematics, the acceleration is 5.39 meter per second square. Next. Okay, in each of the following diagram, the forces cause the body of mass 10 kg to accelerate as shown along the rough horizontal plane. R is the normal reaction. Find normal reaction and the coefficient. So now we have to find that mu. Okay, the same thing, you need to find R, you need to find F, put in that formula to find mu. So you know R, you know F, F equals to mu R, so mu will be F divided by R, and you can find mu also. Try to do this on your own. Next. Same, we have done this type of question, resolve the forces, F equals to mu R, and solve on your own. Okay, I have made the diagram, the end product of this diagram is here, that this is just to help you. Okay, here this is F equals, if you see here, this is friction force, but you know F is mu R, this is mu, this is R, so instead of writing F, it's written mu R, so that you only have one variable R and not F and R both.